Okay, let's create a DFA for this language where W has exactly 2 A's and at least 2 B's. So what we might want to do initially is we might want to split this up into 2 DFAs to make our life a little bit easier. So let's do this W has exactly 2 A's DFA and this W has at least 2 B's DFA separately. Let's do the W has exactly 2 A's DFA first. So we first create our initial state, as we always do. Let's call this state 1. And then let's make a transition A to another state. You'll notice here that if we have a string, let's say AA, right, we're going to feed this in one by one to the DFA. So we're going to say on A, on this first letter A, we're going to go here to this next state. We're going to be on this state after A. So what does this mean? How is this helpful? This means that we need an A to get to 2, which means that we have exactly one A. Now let's say if we feed the second A into the algorithm, where are we going to go? We're not going anywhere, right? But if we create another transition to another state called state 3, if we go back and we refeed the string in, then we know that we're on state 3. So essentially what this is doing is this is counting how many A's we have in our string, which is very useful because that's what this language is trying to do, is trying to count exactly 2 A's. So if we're on state 3, we know that we have exactly 2 A's in the string, right? But what if we have a third A? What if we feed a third A into it, right? Let's create another transition to go to a new state, right? If we have a third A, so let me just erase this to visualize it better. So on the first A, we're going to go here to state 2. On the second A, we're going to go to state 3. And now on third A, we're going to go to state 4. We don't want to accept on state 4 because we have too many A's. That's kind of how this algorithm will be working here, right? And then what about B? So B is not really important here. We're not tracking B at all. So what we can do is we can just loop on B on every state pretty much. And it will just not be a factor. Let's loop on A and B here. Because if we have too many A's, it doesn't matter if we have 3, 4, 5, 1,000 A's, it doesn't matter. We're always going to not accept, okay? So now let's do this next DFA, at least 2 B's. So we'll start with our accept state, as we always do. And then we used this kind of method to track how many A's we have. We can do something very similar. So let's track how many B's we have, because we know that we need at least 2 B's. So let's count to 2. Let's count to 2 B's. Let's try that. So we're going to set up the DFA kind of the same way. So now we have 3 states. So if we're on state 3, that means we have 2 B's. So we know that 2 B's is valid in our language because it fits the criteria. And if we have 3, 4, 5, 1,000 B's, that's also going to still work because it's at least 2 B's. So we're just going to loop on B. And A is not really relevant here, so we can just loop on A on everything. It'll basically, if an A is fed in, it'll do nothing, and that's what we want, right? So let's combine those 2 DFAs and create a DFA that encompasses this entire language. So what we're going to do first is we're going to create our initial state, as we always do. Let's call this state 1. And now we're going to keep track of how many A's we have, as we did before. So let's create a state 2. If we're here, we know we have exactly 1 A, and so on. If we're here, we know we have exactly 2 A's, and so on. If we're here, then we know that we're not going to accept. So let's just loop on A and B and make this not an accept state. We can't make this an accept state like last time, though, because now we have this at least 2 B's part. If we're here, that doesn't necessarily mean that we have at least 2 B's. That just means we have 2 A's. So what we're going to do is we're going to create a transition on B and create another state here. And then let's create another one on B. Remember, we're counting our B's, right? So if we're here, that means we have exactly 2 A's, and then we go down on 2 B's, which means we have 2 B's or more. And if we loop on B, that will encompass basically if we have 2, 3, 5, 1,000 B's, it doesn't matter. If we're here, then that means we have 2 A's to get here, and then at least 2 B's to get here. So we can make this our accept state, right? But now, what about everything else? Because we do need transitions on every state with every letter. So let's kind of do the same thing for, let's build off state 1, for example. So on B, we're going to go down 1. And on B, we're going to go down again. My bad. I'm going to go down again. So now we're counting our B's here. So it is possible to go B, B, A, instead of A, B, B, and still be correct. So that's basically what we're building here. So we go down 2 B's, and then if we loop on B, we know that we have exactly 2 B's, sorry, we have two B's or more. So now all we need to do is check that we have exactly two A's, as we just did up here. So we can just kind of copy that same thing down here. So we can transition on A to another state, and then we can transition on A again to the accept state. So if we have B, B, A, A, we go to the accept state, which is also valid. And we can also have B, A, B, which will be B, A, B, which lands in our accept state, right? So you can kind of see this grid happening here. But this is not complete yet. So what if we have more A? So what if we have B, A, B, A. We add another A onto here. We know that this is not valid, so we need to account for that. So we can go B, A, B, and where do we go on A? We don't want to accept anymore. This is never going to be valid, so we can just bring it up to this dead state. Now what if we have B, A, where are we going to go? We're going to go up here to our dead state because we have three A's, which is bad. So that string is accounted for as well. Now let's create some transitions down here for, let's say an example, A, B, 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 right? So we go A, and then we can't go anywhere on B, which means that we need a transition. So let's transition B down here, and then transition B down here as well. So we can go A, B, B, and we need another transition B because we can't move anywhere on B, which means our DFA is incorrect. So let's add a loop to itself on B, because we know if we're here, we have at least two B's to get here, so we can just loop on itself. All we care about is that we have at least two B's. It doesn't matter how many B's we have, as long as it's more than two, okay? So now this looks pretty close to complete. Let's test some more strings and see if we missed anything. It's very common to miss something because these can get pretty complex. So let's test A, B, A, B, A, B. Let's test A, B, B, B. And let's test A, B, okay? Let's just test these to see if we got it right. So let me erase this. So if we have A, B, A, B, A, B, we landed in a non-accept state, which is correct because we have more than two A's. So we don't want to accept that string. So that's correct. Now A, B, B, B. We land in the non-accept state again, which is good because we don't want to accept. Now A, B, we land in a non-accept state, which is good because we don't want to accept. This doesn't meet our criteria. So it looks like this is a pretty accurate representation of the DFA for this language. Hopefully this helped. And for best practice, let me number my DFA. Sorry about that. So let's go number 5, 6, 7, 8, 9, and 10. Cool. Now it looks like we're finally done.